Okay, couple things before we start going over the review for the test. You are allowed a note card. I am not going to ask for any rules that are not on this review test and what I'm going to go over today. So if it's not on here, you will not need it. So, for example, the two trig problems is going to be a cosine and an arcsecant problem. So those are the only two rules for the trig ones that you're going to need on the index card. You are allowed to bring your calculator if you want. You can use Desmos if that's what you wish to use. That's fine. I will be here as 3:30, so you can come as soon as 3:30 to come take your test. So if you want to come early, take your test, and leave, you're more than welcome to do that. If you want to come early and take 4 hours to do your test, I'm not going to be happy, but you're more than welcome to do that as well. So, but yeah, either way, I'll be here at 3:30, and you have till 7:15 to finish your test on Thursday. So you should not need that much time, but you have it. Any questions generally about the test before we go? Yeah. 15. Exact same as the time and exact same as the review test. Any other questions? All right, let's go over the test. So this is, I'm literally like copied and pasted these questions right from the review test. So if you've done the review test already, these are the same type of questions. I'm just going to go over exactly how to do them. And there are a couple things that came up as we were going through and doing them that will mess you up. So, all right. Find the derivative of the function y equals 1 over x to the fifth minus x squared. All right. How should we go about doing it? Yeah. Yeah, seriously. If you can get it out of the fraction, get it out of the fraction. So let's change this to x to the negative fifth minus x squared. Now we're using the what rule? Nope. Sorry. Power rule. So bring down the negative 5, and that goes to negative 6. So that is the only thing to catch when you're doing these. A lot, keep in your mind that it's negative. So negative 5 minus 1 is negative 6, not negative 4. Minus 2x to the first, so just x. And you could technically leave it like that, or you can just change it back to that. Either answer is acceptable. So either of those would be acceptable. I can't think of another way that you'd want to write this one. So. All right. Any questions on that one? Okay. All right. This one. Very similar to the first one. Only main difference is this one has a root in it. But I would go the same direction as we did the last one. Get rid of that stuff and turn it into exponents. So I'd rewrite this problem x to the 1/3 power plus x to the negative fifth power. So now we get just the power rule. 1/3 x to the negative 2/3 minus 5 x to the negative 6th. If you want to change it back, you can. Nope. Either of those are acceptable. One thing I don't want you to do on your index card, don't write down problem number 1, problem number 2, because they're not going to be in this order. First 12 problems in the test will be randomized. The last couple of questions will be the last couple of questions because those are the word problems. But the first 12 are basically all find the derivative. So it's going to say find the derivative, and they're going to be in a random order. So these might not be in the same order that they're on here. So don't do that in your index card. I've seen that before, and people are going to like, wait, that's not question 1 anymore, and then having to search through the index card to figure out where it is. So don't do that. I'm just doing them in the same order that was on the actual review test. All right, next one. All right, how do you want to do this one? This one looks extremely messy. I will completely agree with that. Yes, correct. So, yeah. Yeah, so this is one of those ones, as it sits, you might think, oh, I got to do product rule. And you absolutely can. And it's going to be a nightmare for you to do. But this is where algebra will really come in to help you. It's something that you really need to start looking at when you start to do these problems. Look for algebraic solutions to simplify it before you do it. This problem, if you distribute the z to the 1/3 through, it actually makes this problem really simple. So if we distribute this through, that z to the 1/3 and that z to the 1/3 cancel each other out. So this ends up becoming negative e to the z minus 2 z to the 1/3. Now that problem looks a lot simpler than the first problem. And you should be able to do this one. This one's actually pretty straightforward. E just stays the same. So that becomes 2 times 1/3 z to the negative 2/3. I'm not going to rewrite this one. I'm not even going to go through and do the first one out of the product rule to show you what the answer would look like. It's not worth the time to do it. Because you'd have to do 2 product rules. I am not going to be picky about variables, except for the x's and y's, make sure they're the same. So like if you wrote the answer and this was all with x's in it, you're getting the right answer. It's correct. So that's another reason to do it on paper. And also show me all your work, because I can give partial credit for the work. So any questions with this one? You could multiply this one out, yes. I don't know in this case if that actually would be any easier, because you'll have 9 separate things, and I don't think any of it's going to combine. So I don't know necessarily if multiplying them out is going to actually save you time. I'm going to do this one as a product rule because I actually think it might be a little bit easier. But you absolutely could multiply it, FOIL it out basically, and do it that way. So product rule, remember, F prime G plus FG prime. So we're gonna, so F is gonna be 2x to the negative second plus 4x to the negative fifth plus 2. So F prime is negative 4x to the negative third minus 20x to the negative sixth. Three x to the third plus 4x to the fourth plus 2. Any questions on those two? So then it's negative 4x to the negative third minus 20x to the negative sixth times 3x to the third plus 4x squared to the fourth plus 2 plus 9x squared plus 16x to the third 2x to the negative second. And even that one, I wouldn't multiply that back all out to break it down or anything else like that. So do you want me to multiply it out and do it out so you can see it both ways, or do anybody care? Okay. So product rule works pretty easy for that one.
The test, do you want us to multiply it out?
No. You can leave it just like that. Again, the key is like, I'm testing your ability to do the calculus rule. That's the calculus rule. I'm not testing your ability to do a ton of algebra after that point. Make sure you don't mess up any signs or any whole numbers or anything else like that. So that's fine. Now, this is one where you might go, oh, this one's really simple. Let me just distribute the e to z through. It will work. It's fine. It actually doesn't save you any steps because you still have to do a product rule. Because if I multiply e to z through, I have 6z squared e to z. I have to do the product rule on that one. So it's not really going to save you any actual time or anything else on this one. You'll get the same answer either way. So I would just leave this one, do this one as a product rule right up at the start. So we have so 12z e to the z plus e to the z 6z squared plus 3. And if you really wanted to simplify it down, that's as far as you could actually go, just by pulling out the e to the z. But you can leave it like the first one. There's nothing wrong with the first one. The thing about figuring out the easiest way to do the problems, that's just practice. That's just the more problems you do, the better you're going to get at going, oh, this is the rule I need to use here. Oh, let me try it, do it this way instead. That's just practice. That being said, remember the topics close Thursday night for the after the test. So if you've not finished the chapter 3 stuff on Friday morning, it'll be closed. You'll be in chapter 4. So I'll have them all in lock after Thanksgiving. All right. Any questions? Yeah. Should close at midnight after the test. I believe I would set it for Thursday. No, you're fine. Yeah, I will look and verify it before I leave today. Because that was the anticipation or the expectation. All right, let's look at this one. All right, what should we do with this one? Yeah, this one is going to be the quotient rule. There's no other way around this one. So remember your quotient rule, f prime g minus fg prime over g squared. So same thing we did with the product rule. Oh, you're right. There you go. So there's f prime and g prime. So now plug them back in. So we've got 1 plus 3 halves x to the negative 1 half times 4 x to the 1 half minus 3x minus x plus 3 to the 1 half. I'm fine with you leaving it there. It might simplify down a little bit, but not enough that actually is going to matter. Questions on this one? If you're not remembering the quotient rule or the product rule, have them written down. But those are ones that I would highly recommend having memorized at some point. This is another one of those ones, like that other one with the product rule, where you might go, oh, I can split this up and try to simplify it. It's really not going to help you much. So doing this one, quotient rules is going to be just as easy. So we've got negative 4x to the third, 5e to the x, minus 7 minus x to the fourth, 5e to the x, over 5e to the x squared. Now this one's one that actually, simplifying it actually does make it a lot simpler to look at. Because I have a 5e to the x in all of them. So I can actually cancel those out. So that actually would be the simplified answer. You don't do it, it's fine. I'm not marking it wrong. I didn't put any questions on the test that asked, well, except for the word problem, the second and third derivatives of them. So this is one of those ones, like if it's asking you for the second derivative, it would be easier to take it from the simplified version than the previous version. So that's really the time when you'd want to break it down and simplify it. It's if they ask you for a second or third derivative. Any questions on this one? Theta is no different than an x. Don't think about it as something different. It's just a variable. It's just a Greek letter that we typically use for angles, but it's no different than any other variable. So f is cosine of theta. So f prime is what? Negative sine of theta. G is 3 plus theta to the 1/2. So G prime is 1/2 theta to the negative 1/2. Oh, I lied earlier. This one could actually be sine. So I'd write down the sine cosine that for little thing if you can't remember it. Sine goes to cosine, cosine goes to negative sine goes to negative cosine, and vice versa. Because this one could be sine. All right. Plug back into my quotient rule. Negative sine theta 3 plus theta to the 1/2 minus cosine theta 1/2 theta to the negative 1/2. That's horrible. Square. Here's the downside to simplifying sometimes. You cannot do that. It's not at all. So just be careful if you are going to simplify. All right. Date. So I just looked at this problem and I go, oh, okay. Let's do the chain rule with this one. Bring it up, do the chain rule. And then I'm sitting here mentally doing the chain rule in my head, and I'm like, it's actually not any easier than just doing the quotient rule. Because what's the derivative of 9? 0. So half the top is going to disappear anyway. So if I set f to 9, f prime is 0. G, I still got to do the chain rule for this anyway. So 1/2. Actually, we'll do the inside first. So the inside is 28x to the 6 plus 6 times 1/2 4x to the 7 plus 6x to the negative 1/2. So remember, chain rule inside times the derivative if the inside didn't exist. So the f prime of g that I have first is gone. So I just have negative 9 times. Actually, I could plot that half. So 9 halves, 28x to the 6 plus 6 4x to the 7 plus 6x to the negative 1/2. Over square root squared is just 4x to the 7 plus 6x. And that's it simplified. If you had brought it up into the chain rule, the only difference would have been it would have been a negative 1/2 for the G because you brought it up to the top, and you'd have had to do exactly the same thing. Nothing would have actually changed. Because when you bring it up to the top, if it was negative 1/2 and you subtract 1, you get negative 3/2, which is what ends up going back up the bottom anyway.
Is that both answers? Or?
Yep. Yeah, I'm not overly worried about the simplification thing. All right, this one, you have to do the chain rule for. So my u is going to be the z to the 4th. So it's u prime. All right. And then I have 7 to the u, which goes to what? There's going to be a natural log in there. So don't try to do it all at the same time. Just do this piece. So this would be 7u ln of 7. And then replace back your u. So g prime of z is going to be 4z to the 3rd times 7z to the 4th times ln of 7. The fear is when you try to do what you did, you're going to forget to put the 4z to the 3rd in the answer. Because if you remember when you're doing that, basically it's at that and it's u times u prime. You will have the one with the ln. So if you don't remember the when the base is not e, I'd write down that rule. One like this will show up.
What's the name of this rule? It's just the power
Well, this is the chain rule. Yeah, this is the chain rule. The other rule that's in there though is the derivative of a base that is not E. So technically E there works too because you get ln of E, which is 1, but it was in section 3, 6, I think we did that. The logarithm section. I didn't put a logarithm problem on the test. Wait, actually, I might have. Nope, I didn't. All right, so this problem was causing all sorts of trouble. Because of the way they asked the question. I will tell you it's not going to be this way on the test. I will have dy over dx. But I want to actually show you this because you are probably going to see this in your topics. And it is actually a nice little thing. And I didn't actually catch it until somebody asked me about it. So the bottom is what you're taking the derivative based on. So typically we do dy dx. So we're taking the derivative based on the x. That's where you get the y prime. This one actually is doing it based on y. So you're going to have x prime as the value that you're going to have there. So in my opinion, I would distribute this. So I guess actually it doesn't really make much difference, but I would just to clean it up a little bit. So we're going to take the derivative of both sides. So this x to the 7th becomes 7x to the 6th, x prime. So unlike before where you typically would have the y prime, and this one you're using x prime. It's over. Now this part right here, I have to do a product rule on. So I have 5x to the 4th times y squared plus, oh, sorry, x prime plus 2yx to the 5th equals 48y to the 5th.
Explain why we use x prime instead of y prime.
Because it's always based on the bottom is what you're taking the derivative based on. So we're doing the derivative based on y. So it's the x prime. So typically it's dy dx. The dx is on the bottom because we're differentiating based on the x. But like I said, the test will have dy over dx. All right. Now, when you have this, we want to get all the x primes on one side or the y primes, depending on what you're looking at, and all the rest of the stuff on the other side. So in this case, the only thing I got to move over is that piece. So I have 7x to the 6th x prime plus 5x to the 4th y squared x prime equals 48y to the 5th minus 2y x to the 5th. Then we factor out the x prime. And we divide over by what we have left. And that's your final answer. Any questions with that? Anyway, last chance to ask questions before you test. So
That product rule that you use to get, 5x to 4.
yes. Yeah. So f would be x to the fifth, y or g would be y squared. No problem. Not at all. Yeah, I kind of did that one at the same time. Now you know what my high school kids do all day. All right. Here's a question you asked me before. This is the only inverse tangent one you're going to have on there. And it will be arc cosecant. So if you're like me and you have to look it up, I'd write it down. I don't remember it off the top of my head. All right. So the nice thing about the way this rule is written is u is whatever's inside. So in this case, my u is what? Is 8x. So then u prime is just 8. So g prime of x is negative 8 over the absolute value of 8x, 64x squared minus 1. And I'm done. That's why those rules are so important for those. It's because it's literally plug and play once you have them. I have memorized them, so I don't expect you to memorize them. I looked it up just now. It's not something you use quite often, so you're going to look it up. So that's why I would have that written down in your next card. It will be the arc cosecant one. I can't guarantee the middle is going to be 8, like a single number with x, but it will be an arc cosecant. Don't forget the absolute value. That is not optional. If you forget it, you're not going to get the whole problem wrong. But I probably will take off a couple points if you forget the absolute value there. Because in this case, 8x can be negative, and in cosine or cosecant, it cannot be negative. So that's why the absolute value is there and why it's so important. All right, that's the end of the just plain derivative problems. So the first 12 questions of the test will be randomized. So this depends on how I randomize them tomorrow. All right, off to the word problems now. So your 3-word problems, one is a position, velocity, acceleration problem, and the other 2 are related rate problems. So we have y of t equals negative t to the third plus 7t squared. we want V of t and A of t. V of t is what? What's the relationship between the y of t and the v of t? Yep, and then the A of t is your second derivative. So find my derivative. So I get negative 3t squared plus 14t. And then find my derivative again. This comes up on the longer questions. Each question on the test is worth the exact same number of points. So there's 15 questions on the test. Each question's worth 7 points. Okay, so the first 12 questions are worth 7 points. This question's worth 7 points, which actually means it adds up to 105. So there's 5 little wiggle problems, points in there for you. That means that when you're going through, especially on this problem, showing me this step, if you screw this step up when I'm looking at your problems, I might give you points for the y of 3 and stuff like that because you plugged it in correctly. You screwed up the derivative at that point. So I might take away those points, but not the other ones. Where if you don't show me this and you get the number wrong for the y to the third, those things, then it's just wrong. So now we plug in 3 to each one. So negative 27 plus 63. I guess. What's the V? Save me the trouble of trying to do this in my head because I don't feel like grabbing a calculator. $15? Sounds right. 42 minus 27? Yeah. And then A of 3, negative 18 plus 14 is negative 4. All right. So where's the particle located at t equals 3? At, below, or above? Above. It's a positive, negative thing. That's all you're looking at for this one. So if it's positive, it's above, upwards, speeding up. If it's negative, it's below, downward, speeding, or slowing down. And if it's 0, it's not changing. For the velocity, is it traveling upwards, downwards, or staying the same? Upwards. Because velocity is increased, is positive. Is it speeding up or slowing down? It's slowing down because it's negative. Any questions on this one? Last two, related rate problem. All right, draw me a picture. All right, it does end the 16th at 11:59. That's Thursday at 11:59. So this one, we kind of have a similar triangle type situation going on. So a man's 1.8 meters tall, walks directly towards the light pole at a constant rate of 1.4 meters per second and casts a shadow onto the sidewalk behind him. So light pole, get my wonderful drawing skills now. Shadow. He's 1.8 meters tall. The light pole is 4 meters. And he's moving this way at 1.4 meters per second. All right. So what do we know? What do they give me that's going to help me? Huh? Right. Okay. Well, his height's not going to change, right? His height's not going to change. So the speed. So what's that? 1.4 meters per second. So that's how do we want to label this? dm over ds is 1.4 meters per second. All right. What else? We got to set up the. Let's set up the bottom part. The actual relationship between the two. So what is my oh, it's a light outside. My picture is horrible. I'm gonna get a better picture. Ignore the numbers on this for a second. And this actually is going to matter. But here's a better picture. Ignore the numbers. Is it 6? Was it 6 high? 4 high. And it was and he's going that way. That matters. So the direction that he's walking to the light actually makes a difference. So in this case, he's walking towards the light. And the problem that the picture I just copied, he was walking away from the light. That's going to matter in terms of the sign of your answer. So this word right here can change, and that actually will change the answer to the problem. Okay, so be careful when you're looking at that. All right, so what is my ratio that I have set up here? What was it? Okay. So we can solve this for y. So let's cross multiply. All right, so what's the derivative? So if you take the derivative of both sides of this, we get 1.8 over 2.2 x times d over dt equals dy over dt. Because remember, we're differentiating based on the t. So this problem said the x was 6. So 1.8 over 2.2 times 6 times 1.4. And it's negative 1.4 because it's going that direction. the x is getting smaller. Something's wrong. Oh, the x finished. That's a mistake I made. I forgot to take the derivative with the x. The x is gone. I'm like, I knew something was off there. That's it. So we get negative 1 point, and that's, I think they wanted it rounded to 2 decimal places. Yeah, there's hundredth. So negative 1.15. All right. Second part of this question. Based on the answer to part A, is length of the man's shadow increasing or decreasing at a constant rate when he's 6 meters from the pole? Decreasing.
That's just based off the sign.
Correct. It's only totally based off the sign. And if you think about it, as closer and closer you get to the pole, less of the light's hitting you. When you're at the pole, your shadow's going to be zero. So it kind of makes sense that as you're getting closer, the shadow is getting smaller. All right. Last one. Huh? No. This one's not similar triangles. This one's a trig problem. So you'll have one that's similar triangles, one that's trig. That's when we're talking about related rates. Those are the two things that I said we we're going to have.
These are the two types of
Related rate problems. Yeah. This one, that word makes a difference. So when you're reading it, traveling away or traveling towards, that matters. Okay. All right, so we've got to come up with a couple pieces of information for this problem. So first thing, draw our picture. You can ignore my picture for a second. I got to change numbers. All right, so now our problem says 8 kilometers. So that's 8 kilometers. And it was 1 revolution every 50 seconds. And we're going away. So we're going that way. And we want to know when that is 2 kilometers. But we don't quite know that one yet. So actually, I'll leave that one off for a second. All right. So we kind of need to change this 1 revolutions over 50 seconds into a radian that we can use. So how much is 1 complete revolution in terms of radians? 2 pi. So I've got 2 pi is 1 revolution. So that's 2 pi over 50. That's going to be my radians, or pi over 25. That's rad over seconds. Because that's what they wanted it in. So if you looked at the question, because we're going to get, so that's my d theta dt. It's the change in angle over time, because the lighthouse, the light's moving. And since in this case it's moving away from P, it's a positive. If it was moving towards, it'd be a negative. D theta over dt. All right. So now we have to set up a relationship between theta and y, because that's the value that I'm going to have. So that would be opposite, that would be adjacent, so it's going to be tangent. So tangent of theta equals y over 8. Or 8 tangent theta equals y. So now we need to figure out the derivative of that. So what's the derivative of tangent? Secant squared. d theta dt equals dy dt. All right, so now this question tells me that it's 2 kilometers, so this is going to be 2. We can use Pythagorean theorem to figure out my hypotenuse, because secant theta is hypotenuse over adjacent. So I've got square root of 2 squared plus 8 squared is the square root of 68. So we've got 8 square root of 68 over 8 squared times pi over 25. This comes out to be 1.068. Which is 1.07. So that's 1.07. So is the distance between point P and the beam on the wall increasing, decreasing, or constant? Increasing. And honestly, if you look at this, it totally makes sense. The beam's going that way. So that's your test. Any questions with it? All right. If you have no other questions, you're free to go. We'll see you on Thursday.